Alright, so this is partitioning a line segment notes. 2. Partition a line segment. Means to divide the line segment into a given ratio. The two numbers in the ratio must add together to equal the total number of pieces. That's the key part too. Make sure you add those numbers together, because we're going to end up dividing by those numbers at the end when we do our math. Alright, down here, let's talk about this first. A ratio itself. Some of y'all don't know what a ratio is. A ratio is just it's like a fraction or a ratio, usually in fraction form, just showing you the split of a certain set of numbers. So the ways you can see it, the main way we're going to see it, say if I say a ratio is 1 to 3, we'll do it like this: 1:3. Or you can see it like this with the word 1 to 3. I will do it in fraction form, 1 to 3. A ratio though. Down here on these little number lines right here, it says label the point P that partitions the line segment AB onto the ratio of 3 to 2. So all you're doing is splitting this line AB into a 3 to 2 ratio. So going from A, we're splitting 3 to 2. When we do that, my partition point P will be here. The other thing you want to know for future reference is just how many segments you have in total. To figure that out, just add the split together. It's 3 plus 2, 5 segments in total. The second one, they want me to split 1 to 4. That's my 1 to 4 split. My partition point P will be right here. Total number of segments, 1 plus 4, 5 segments. Last one, 2 to 3 split. Two, 3. My partition point is here this time. Yeah, that's easy. But it's gonna be, our stuff gonna be on the graph though, so it's gonna be a little bit hard. And this ain't just gonna be splitting it like this and saying P. On the graph, we're gonna do some math, but not bad though. Yeah, determine the ratio of the directed line segment AB when partitioned by point P. So this is reverse. They give you a segment, they show you the partition point. They just want to know what the ratio is. Jennifer, what's my ratio for this first one? 1 to 2. If it's 1 to 2, how many segments do I have in total?
3.
You're good. Don't worry. You're coming up. Yeah, don't count the points. Count space. Tanaya. 2 to 3 for the second one. How many segments in total? 5. Last but not least, Jonathan.
5 to 1.
5 to 1. 6 segments. I know we went fast, but it just seems kind of obvious. Anybody struggling with that though? Y'all want us to count for y'all? We can. No, I'm being serious. I'm not even like joking. You sure? Alright. I ain't gonna say your name, we recording. Okay, so this is partitioning on the coordinate plane. Got some steps you want to take here. Similar to what we just did, except for there's a couple of extra steps added in. Step 1 is what we were just doing up top here. Determine the total number of parts the line is divided into. Step 2, you need to determine the weight to apply to each coordinate by flipping the ratio. So that's the only part, and that's the new thing I'm showing you, and this is different than how I used to teach it, but it's just easier to do this versus like going on the graph and counting and doing all that. That was a lot for kids. This easier to just do this. Determine what your weight is and then flip the ratio. I'm going to show you what I'm talking about when I say flip. After that, we're going to multiply each coordinate that we get from our line segment, our original segment, by the weight from the flip ratio. Then we're going to add them together. And then the last piece, we're going to divide the sum of our x and our y coordinates by the total number of parts found in step 1. So by the total number of segments we have. Alright. Not bad. It's just going to be repetition. You'll learn how to do it.
That's funny.
I'm sorry, good. That means it's killing what it needs to kill.
It's not good.
Alright, on the back, let me go ahead and put my mask on for a little bit. Alright, given points A, 3, 4, and B, 6, 10. Find the coordinates of P on a directed line segment AB that partitions A, B, in a ratio of 2 to 1. Alright, so I used to have graphs on all these, but I took them off because you don't really need the graphs no more if you do it this way. The old way I used to do it, you used to need the graph. But I'm doing it a new way now. That's why we're re-recording. For this, I just want you to draw a little segment so you can just label and keep up with your information. The first thing, before we even draw that segment, let's get our total number of segments. It's 2 to 1. How many segments do we have in total? 3 segments. We're going to need that because that's what we're going to divide by at the end. Alright. After that, I'm drawing my segment. They told me to partition the line segment A to B. That's going to be important because sometimes we do switch it up on you. So they want me to go A to B. So put A over here, put B here. And then my coordinates for A were at 3, 4. My coordinates for B were at 6, 10. After that, this is that step 2 right that we were talking about where it says flip the ratio to multiply by the correct weight. So my ratio is 2 to 1. What I want to do is flip it, and I want to multiply my first coordinate A by 1, my coordinate B, my second one, by the first number 2. So I'm basically going to flip and multiply by the last number and first number. So I'm putting the 1 here, the 2 I'm putting here on the other coordinate on B. And so now I'm multiplying by 1 and 2 versus the 2 to 1 ratio. That's what I'm talking about when I say flip. That part is key. If you don't do it, you ain't going to partition right. Oh, I ain't telling you what I'm doing. After that, I'm multiplying the coordinates by 1 and by 2. And that's just distribution. I'm distributing that 1 to the x and the y value. I'm distributing that 2 to the x and the y value. And then I'm going to stack so I can add them. So we'll do this first. 1 times 3 is 3. 1 times 4 is 4. Obviously, that coordinate ain't going to change. It's going to be 3, 4. The other coordinate is going to be 2 times 6, which is 12. And put that under here. We're stacking. And then 2 times 10, which is 20. I'm stacking so I can add these coordinates together after I multiply. So 3 plus 12 is 15. 4 plus 20 is 24. So my coordinates after I add it together is 15, 24. Last thing you need to do is divide by the total number of segments. So we're going to divide by 3. Both of them. 3 here, 3 here. 15 divided by 3 is 5. 24 divided by 3 is 8. That would be my partition point at 5, 8. If we want a graph, I would put a P at 5, 8. That would be my point of partition. On the ones at the bottom, we're going to... Alright, so we're moving on to number 2 now. Same situation, just different coordinates. So, oh, this one is B to A too. So I hope you ain't go too far ahead of me. Given the points A and B, find the coordinates of point P directed on the line segment B to A. That partitions it B to A in a ratio of 1 to 2. So first thing again, how many segments? It's 3. And then on this one, this is where you kind of got to make sure you do it the right way. This one's B to A. B here, A is here. B is at 6, 1. A is at -3, -2. And then we're still doing the same thing we did on the first one. Our ratio was 1 to 2. We need to flip that to apply the way, huh? What? What I wrote one.
I did.
It's okay. We only record. No, I was messing with you. That's fine. No, 1 to 2. So we're multiplying point B, our first point, by the last part of the ratio, which is 2. Second point is going to be multiplied by 1. So we're flipping it. 2 here, 1 here. Two times 6, 12. 2 times 1 is 2. And then on this one, it's 1 times -3, -3. 1 times -2, -2. We adding these coordinates together. So it's going to be 12 plus -3, which will be +9. And then 2 plus -2, which will be 0. So 9, 0. Last thing you need to do is divide by the total number of segments, which would be 3. Here and here. 9 divided by 3 is 3. 0 divided by 3, 0. On this next one, we're on the graph, so at least I'm going to be able to show you at the end where the partition point actually is, too. Alright, let's keep it rolling. Number 3, find the coordinates of point P on the directed line segment AB that partitions AB in a ratio of 1 to 3. Terry, how many segments we got? 4. So remember, we divide by 4 at the end. Alright. This one's on the graph. So they don't give you the coordinates, but they're on the graph. We can easily pull these coordinates off the graph. It told us to go A to B to. Where's point A at? -4, -3. Point B. 4, 1. Alright. Next, we need to make sure we multiply by the right thing. Point A, what are we multiplying it by? 3. Point B, 1. Negative 4 times 3 is negative 12. Negative 3 times 3 is negative 9. And then you got the 4 times 1, which is 4. And then 1 times 1 is obviously 1. I don't know why we're doing that. We know when you multiply by 1, it's just going to be the same thing. Negative 12 plus 4, negative 8. Negative 9 plus 1, negative 8. We're dividing by 4. Negative 8 divided by 4 is 2. Negative 2, sorry. And then, same thing. So this is telling me that my partition point is at negative 2, negative 2. And that'll split my line into a 1 to 3 ratio from A to B. Let's see if it does that. On the line, on the graph, negative 2 is right here. That'll be my P. And yeah, it splits my line into a 1 to 3 ratio. What's up? At the top, 1 plus 3. I just showed you 1 plus 3. The ratio. That's what we were doing on the front of the notes, like the whole time. Alright. Number 4. B to A. Get your coordinates. Do a 3 to 1 split. You do it. We're back. We're doing number 1 on practice. Alright. So this line segment AB, the partition is 1 to 3. So I'm flipping my ratio. Times the point A by 3, this one by 1. Distribute, 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 distribute. First one, 3 times negative 1, negative 9. 3 times 2, 6. And then it's just times 1, so 7 and 8. Alright, negative 9 plus 7, negative 2. 6 plus 8, oh god, 14. I feel like I did something wrong.
Where you getting 9 from?
Right.
It should be 3. Don't yell at me.
Thinking I messed up.
I say this ain't about to come out right. I feel like I did something wrong. It's supposed to be a 3. My bad. I don't know why I thought I was negative. 3 times negative 3. I'm tripping. So this should be what? Positive 4? Yes, no, maybe. Yeah. We all make mistakes. So it's 4 and 14, children. I forgot to get my total number of segments up here. It was 4 segments. So we divide them by 4. You're going to get 1 right here. And this way you run into the issue at 14 divided by 4. You're not going to get a whole number. What's the decimal though? 3.5. That will work. That's a decent decimal. Decimals I'm talking about that you want to leave as a fraction if they like say you do something like I think it's gonna come out long 15 divided by 7 or something like that, and it gets something ugly like that, yeah, leave that as a fraction. But if you get a clean decimal like this, that's cool. Another one I wanted to do with you, number 3 on home learning. And all these problems are asking the same thing. It's just that we write them a certain different ways. And I told y'all this on another set of notes. Just because I never know on a test or anything how somebody else who's writing a test, like a PMA or your EOC, I don't know how they're going to write your questions. So I try to present them in all different kind of ways, like so you can understand that all of these are asking the same thing. All these questions on both of these pages actually the partition line segment. We just wrote how we asked it differently, so you can be exposed to being asked the same question multiple types of ways. Number 3, point P is located on AB such that the ratio is AP to PB. Like, kids are getting stuck in that. All it's saying is, like, when you put point P on your segment, it's going to split your big segment into a ratio of A to P and P to B, which is 2 to 3, which it will. And then which is 2 to 3. It's not actually nothing different. It's just telling you what it's going to look like on the graph. If the coordinates of AB are A and B, I don't feel like reading that. What is the x coordinate of point P? Alright, on this one. The reason I'm doing this one, if you look, there's only one box down here. That's on purpose. It's not 2 boxes like it's on. It's only asking us for the x coordinate. We don't need to do both sides. But I will for the most part anyway. It's just at the end, I'm only going to divide the one side, the x side, by whatever my total number of segments is, which is 5. Might as well write that up here now. 5 segments. I only care about the x value. Alright, so A to B. Point A is at -3, -4. B is at 5, 0. We're timesing point A by 3. Point B by 2. Three times -3, -9. 3 times -4, -12. Pretty sure that's right. Under that, 2 times 5 is 10. 2 times 0 is 0. Adding those together. -9 plus 10 is 1. -12 plus 0 is -12. Once again, when I get to this point, I really don't care about the y. I didn't even have to do that. I only care about my x value because I only want the x anyway. So I'm taking my x value, 1, dividing it by 5. One divided by 5, 0.2. And that's because they asked me to find x on this one. If they ask you to find y, just worry about the y side. Like, for example, number 4 asks for the y coordinate. So just worry about the y side when you get there. On number 4. On home, man. Alright, I gave y'all enough examples. Y'all in good shape. Y'all can finish that. It's open to online whenever you want to submit it after you finish.